Alright, so this is the notes, for example, for nonlinear systems, and this is in conjunction with your graphing calculator. So here's what the problem actually is on paper. I'm going to kind of show you how I draw this out as far as graphing it and getting the intersections if you're asked to do so. So a lot of these points and the references are going to come from my graphing calculator, which is in a separate video on how to actually put these in the graphing calculator. So on this one, we do have it in there, a video in there on how to do on the graphing calculator. I already put them in there. So what I do first is I plot my intersection points. One point is -1 and -9, so all the way down here. And then the other point is 3, 7, right there. Okay, so the line equation is really easy to graph. All I'm going to do is just basically draw a line that goes through both points. It can be trickier at times. All right, so there's my line. And then I'm going to draw my parabola that goes through both points as well. So usually I try to reference some points on my parabola like a root or a vertex, especially a vertex. And this one, the bottom intersection is at the vertex of the parabola, so in green here. I have a parabola that comes around and then it'll intersect here, and then I'll just kind of draw off the other side. So not terribly accurate, but it gets very similar to what the calculator shows me. Okay, so basically, as I said, these intersection points are key. So you just basically graph the equations in the system and you find their intersections. So here I have one intersection at -1, -9, and 3, 7, and these would be the solutions to this system.